Good. Hey guys, I'm Ian. I'm a senior studying mechanical engineering.
Hi, and I'm Allie. I'm a junior studying industrial systems engineering, and we are going to give a tour of the SAE Racing shop. All right,
So, I am the president of the team, and I'm going to give you guys a little bit of background on what USC Formula SAE is, and then we'll go and kind of interview a couple people in the shop and see what's going on.
Awesome.
So, the Formula SAE team, SAE stands for Society of Automotive Engineers, and the Formula competition is a competition that requires students to build a car, and that, as you can see right here, and race it in either a competition in Lincoln, Nebraska, Michigan, or a lot of European countries once a year. And so the Formula SAE team is divided into several different groups. There is the business side, which I manage. There is the chassis team, the composite sub-team, which Allie is on.
Hey!
The electronics sub-team, and the powertrain sub-team. So as we go around the shop, we'll give you a little bit of insight into what's going on and a little bit more action.
Awesome. So this is the electrical engineering side. So you can see welding goes on over here. Here's some heat guns, heat rays, tires, and here's some past hoods of our cars, the nose cones, which is pretty cool.
From left to right, you've got oldest to most recent.
Cool.
And then it's a little bit messy, as you can see, but this is what you're going to find in the Formula SAE shop.
You want to talk about this car?
Yeah, I was actually going to mention, so this is Stacy. This is our car from the 2014-2015 competition season. And as you can see, it's our first car. It's the only car together in the shop. Over there, you can see next year's chassis going together. But Stacy, we raced back in June of last year when we went to competition in Lincoln, Nebraska. And this is the first time that we've actually been able to keep a car together while building a new car. You notice that we have all the arrows still on it. It's actually being taken apart a little bit right now to actually get more data acquisition devices on there and to update the electronic systems. And so we'll go through and start talking about what's going on with the rest of the shop right here. This is a Siri. Say hi, Siri.
How's it going?
We're periscoping. So.
Oh, okay.
Live tour. You want to talk a little bit about what you're doing right now?
Yeah. So right now we're trying to figure out the steering for this year's car. We pretty much size all the tubing.
So you can see the steering rack going in.
Yeah, so the steering rack's in. We measure everything out. We just put the bearings into its bearing speed. And yeah, so hopefully it'll be done by tonight.
How many years have you been on the team?
Since freshman year.
Hey!
Since day one.
Also a mechanical engineer. Also a senior.
That is also correct.
You've been doing brakes since last year, working on chassis.
Yeah, so I did brakes starting my sophomore year, and then just picked up like frame and now like most of the chassis. Yeah.
Dope.
So
cool.
Awesome.
Just walked over. This is Jason Zide.
Hello.
This is the team's design lead. And over in the shop, we've got Michelle. But you want to explain a little bit about the team or what you think is relevant?
And what you do.
And what you do.
I am design lead, so that means I'm responsible for the design of everything on the car. So I work with all the different sub-teams to make sure that the designs are working and they're going to be substantial enough to actually work when they go on the car and are at competition, and also make sure that everything will work together. So we have probably 1,000 different components on the car, and we need to make sure that this part isn't interfering with this part and the two things aren't trying to be in the same place at the same time. So there's a lot of work that goes into it, a lot of time spent on CAD, but also a lot of time spent here actually building the thing, which is a lot of fun.
What was your history on the team before you became design lead?
So before I was design lead, I started out as a freshman working on powertrain team. My first project was actually designing the headers, which are right here, if you want to look at them.
Cool.
Yeah.
We also just got an hello from LSU's FSAE team.
Oh,
so they're
tell them
watching.
hi.
How's it going?
You can see our shop.
So after working on powertrain my freshman year, I became powertrain lead my sophomore year. Following that, my junior year, I was project manager, and I was that again the following year when I took a year off to go work in England, and then I have returned as design lead this year to England. In England, I worked on a Formula 1 team this month as a design engineer in the gearbox department, which was a lot of fun and got to use what I learned on Formula SAE at USC in England working on a Formula 1 car. So yeah, it was a great experience.
So I just brought over Anshul.
Bye everyone.
Bye Jason. So this is Anshul, he's our team's project manager, and do you want to tell them just a little about what you do on the team?
Sure.
So I work closely alongside Jason.
Here, wait, let's
leading-
move away from the music just in case
Okay, yeah.
it's compromising.
Over here. So pretty much what I do is I take all of the designs that Jason and the others work on and figure out how we can actually manufacture this. You know, each individual part, working with our team doing stuff here in the shop.
They're
working
saying
with-
that rapid prototyping intake. This
Yeah.
is LSU's
Yeah,
MSA team.
yeah, we're very proud of our 3D printed intake. It's pretty awesome, if I'll say so myself. So yeah, you know, and then of course once we have all these components, they have to come together. So that final build of the car, then testing the car, fixing stuff, changing stuff, kind of do my best to manage all of that
Yeah,
stuff.
so Anshul's basically responsible for making sure that the car gets completed in time for competition and hopefully in time for a lot of testing prior to getting to Lincoln. So we'll see you guys there. I'll see you.
And
so-
can someone explain what this is?
Yes.
So
I'll go.
yeah, so these are some of our molds for our bodywork on the car, and this giant one right here in the middle is for our under tray.
Tell LSU they're not allowed to see it.
Yeah, LSU, you
They're
have to
saying we're
close your
sharing
eyes.
all of our secrets.
Yeah. So this is, we're going to make a big piece of carbon fiber using this mold that's going to be underneath the car and pretty much suck the car to the ground and let us go around the racetrack way faster.
Cool.
Yeah, you want to give a little bit of explanation of what an under tray is, just again to
Yeah,
reiterate.
so it's just a way of directing the airflow under the car so that you make a big pocket of low pressure underneath the car, and it's like the opposite of a wing. You're basically trying to suck the car downwards, and it's the same thing as like the wings that you see up high on the car. So
Adds
yeah.
downforce.
Downforce.
Back here is actually where we do our carbon fiber work.
So we've actually made a kind of janky but very functional oven. So if you see below right here, actually, we've been able to lay up our wings inside this really cool homemade oven that we finished last
Okay, you can
semester.
see all the heat guns around. This is my department. So
Yeah.
This is Allie's especially.
Here's a
Yes.
sample piece of wing. Here's
Cool.
one of our molds. That's going to be a side pod on the car. You can see some of the kind of molds that we use to make these wing elements here. So believe it or not, this is actually a foam, and we do some pretty nifty surface treatments to make it really strong and super smooth.
yes,
So
lots of sanding and
Yeah.
waxing, wax on, wax off,
Prior,
times 100.
Prior
Here's
to
some
laying
more
up so that we get this final
foam
finished
molds.
product.
Yep, it's very
which is really
pretty.
smooth. You can see over
Yeah.
here.
We're, yeah.
Yeah, so it starts off. This is not exactly from this one, but a similar
Yeah,
type.
it's just like
of
a fabric.
Thread, fabric, exactly. And then we lay it up with our pre-preg. And this is one that's actually on a mold right now.
We pulled this one off. So this
Yeah.
was just a test piece. Doing some tests with adding in different materials to make our wings
Yeah, so this is
stronger.
actually really cool. So this is like this little honeycomb thing that we put inside. That's these little strips, and it makes it much stronger than without. So it's a really light and efficient way of making it stronger.
Yeah, you see that a lot on like commercial airplanes. Actually, they use this kind of honeycomb all over for like wings and structural parts of airplanes.
Targeted structural improvement. So, to explain a little bit more about the competition, the competition is divided into a couple of different events. So, on the static side, you've got cost, design, and the business logic case. And so the cost actually takes a cost breakdown of what it takes to build a car. And essentially, you're imagining that you're going to produce about 75 to 100 of these cars and trying to sell them on the mass market. And so what the competition does is they outline a bunch of prices that each of the operations would cost and all of the pieces would cost on the car. And you tally that up and submit your cost report. And then for your business logic case, depending on what the cost of the car was, you propose a way of selling these cars on the market and trying to make a business out of actually manufacturing this car. The design aspect of the competition allows us to break down why we made all of the decisions on the car. So why we put a bolt in a certain place, or why we packaged the engine the way we did. You'll notice if you look at pictures of Formula competitions, you'll see that cars are very, very different from each other. Some have wings, some don't have wings. If you don't have the capability to lay things up in your shop, then that's the case.
Okay, we're getting some questions in. Sorry to
of course.
interrupt. Why isn't your frame aluminum, and how fast does the car go?
So the car goes 0 to 60 in about 3.6 right now, or 3.5. The frame isn't aluminum because
It's a guy from Alice.
Oh, really?
Yeah.
Okay. So the frame is aluminum because of we've used last year's setup, and we've actually gone through because of the competition's requirements. We actually stuck to the steel frame. So
Cool.
more questions? Okay.
Yeah.
So to break down the next part, the dynamic events of the competition. So it starts out with a skid pad test, which is essentially a figure eight. You go around twice on each side, and that measures the lateral acceleration of the car. Then there's the acceleration test, which is your 0 to 75 meters, and that's straight sprint. There is, after that, an autocross, which is about a 45 to 60 second lap. And then finally, there's the endurance race, which, you know, a lot of us fall out of competition at. It's a really grueling 22-kilometer race, and there's a driver change in the middle. So the challenge is all of the different aspects of the car, and because these cars are built in just about a year, it's really difficult for a lot of teams to make it through the entire competition. And actually, almost 50%, and sometimes more than 50% of the field falls out in the last race, which is worth about 40% of your points.
Wow.
So, come back to
Okay, so for those of you guys just joining in, we are in the USC FSAE race car shop.
Yes.
So we have just talked about the composites over here, which is the team that I'm a part of, which is basically any part of the car that you can see made out of carbon fiber. And now we're here again, just to check out what they're doing over here, and then I think we'll wrap things up.
Yeah, let's make sure your glasses are free.
Oh yeah, true. Safety is very important. Now I'm getting, why is San Jose State University so good? All right, guys.
Okay.
You said hi now?
San Jose.
San Jose State can
Yeah.
figure out why they're good.
Everyone's trying to steal our secrets.
Hey.
Hey, how's it going, Ellen?
Changing up the steering rack.
Yeah, we'll be instead.
Gotcha.
All right, what's going on over here?
What's up? So we're actually trying to fix this mold. So we use molds to make our carbon fiber parts. So we need them to be as smooth as possible. So we're basically sanding down part of it. So
Cool.
Just cleaning it up.
yeah, basically.
So trying to improve the final product.
And Ian, do you know what this is?
Yeah, so this is just a digital readout of our lathe. The lathe is obviously for turning parts. Just a minute ago, Jason was working on it to improve fix our steering rack. Column.
This feels dangerous.
And we can show you guys a little bit about how it works, or just watch it.
Yeah. Cool.
Yeah.
First thing to know. 220 should be good. Okay.
So for those of you that are just joining us, these are the molds for, this is the under tray and our nose cone over there.
So a little bit more about our team in particular. The team is entirely student run and entirely student funded and fundraised. So we actually get a lot of our parts manufactured by sponsors. In fact, like the molds that you see here were cut by a sponsor. The actual foam was donated by a sponsor, and then we actually glued it together ourselves. All of the cuts on our chassis, all the pipe or all the tubing was cut by a sponsor, and then actually was welded in the shop. So
Very cool.
everything you see here is really done with our own hands, with as much help as we can get. We try and raise as much monetary funding as possible, but it's a pretty difficult competition to do. So.
And one of the advantages we have in LA is that we're surrounded by aerospace companies.
Yeah, so the aerospace corporations, Boeing's on our previous car. You got AirTech, National Instruments has been a sponsor in the past. There's a lot of ones that are normally sponsoring the competition. But they're all super, super helpful in making sure this car gets done. And thank you to all of our sponsors for everything you do for us.
Small plug.
So.
I think we're good. Does anybody have any more questions?
Suggestions?
Finish up here.
Yeah.
Oh yeah.
Suggestions for our new car name, we'd love to hear them. You should also go like our page. It's USC Formula SAE. It's on Facebook. We're trying to get to 1,000 likes, and if you guys can help us out, LSU, hey, toss us some our way.
Yeah, so I think we are
About done.
all good. Thank you guys so much
thank
for
you
tuning
guys.
in. If you have any more questions, definitely tweet at us. We'd be happy to answer anything you have.
Yeah.
And
Sounds good. Fight on,
right
guys.
on.